Yes, hi guys, we are continuing the chapter 7, grade 10 about the mirror. General equation of the spherical mirror. This mathematical relationship is called general law of mirror. First, how we can find the length of the focal length of the mirror, and how we can find the distance of the object from the mirror, or how we can find distance of image from the. We are using some simple equations. 1 over f, it's meaning the focal length of the mirror equals 1 over u. If you remember the last lesson, we showed what is the u, or the objects, the size of the objects, and if you remember size of the object and distance of the object to mirror, and the size of the image, and this distance between the image to mirror. If you remember, u, the distance of objects to mirror, plus 1 over v, it's meaning the distance of image to mirror. When we are asking any question about the focal length of the mirror, or distance of the object, or distance of the, we are using this simple equation. For example, this equation we are using for concave mirror, but we are using the convex mirror, same equation, only one different things. And if you remember about the convex mirror, the image is not real, virtual. If any image is virtual, we are showing the minus. Minus, it means the object image is virtual, or we can understand the mirror, it can be convex mirror. 1 over focal length equals 1 over the distance of objects. We can show the objects or u, and minus 1 over distance of image. We can show the image, or we can show v. Why we are showing the focal length? It is minus. Minus f, or minus focal length, in this equation indicate that the focal length of the convex mirror is behind the mirror, and minus distance of image means that image formed by convex mirror, and image is virtual. And another and last equation about the mirror, magnification law in the mirror. The ratio between the length of the image formed in the spherical mirror to the length of the object is called magnification. We can show magnification capital M, and it is equal to ratio of image distance to the object's distance from the mirror. We can show capital M, it's meaning magnification equals, if you remember what is meaning the v, what is meaning the u, the distance between the object to mirror, and distance between of the image. And if you remember about the h power over h, the height of objects, h power height of image, h power over h equals about the distance. Look at this, it is minus be careful. When we are using about the distance, we are using the minus the distance between the objects, distance between the image over distance between the objects. Magnification for spherical mirror. The magnification M of the mirror is defined as the ratio of image height to object's height. And some, when we are applying about the magnification law of the following should be know, or we should memorize some properties. It is giving the shortly answer. But when we are using the equation, we can find this result. Firstly, length of the image is positive for erect image, upward, and the negative for invert image, downward. Second, length of the object is positive for erect. Erect meaning upward, and the object is negative for inverted object is downward. Magnification sign is negative when the image is real and inverted the objects. Magnification sign is positive when the image is virtual and erect objects. If you look at this, magnification sign is negative, real and inverted, but if you positive, virtual and erect, opposite meanings. What about the magnifications? If magnification bigger than 1, then image is magnified to the objects, and if magnification is smaller than 1, then image is minimized, the objects smaller than objects. If magnification equals to 1, the image is equals to objects, it means object stays center point. The magnification sign is positive for image erect or upward, and it is negative for inverted real image or downward. These notes we can memorize, or when we are using the equation we can find this result. Example: a concave mirror having a focal length of 20 centimeters. Find the location of the formed image and its characteristics and the amount of magnification for an object placed at the distance 30 centimeters in front of the mirror. First, when we are writing the given and question, it is giving some informations. For example, it is giving focal length equals 20 centimeters, and question, it is giving the distance of objects equals 30 centimeters, and we will find the distance of image. Firstly, this one is. Secondly, it wants magnification how much. Firstly, I will using the two equations. Firstly, we will find the distance of the image. If you remember our equation, 1 over f equals 1 over the distance of the object plus 1 over distance of the image. And we know focal length 20 centimeters equals 1 over 30 plus 1 over v. 1 over v, or 1 over the distance of the image, equals 1 over 20. When we are sending the another side, it is changing the positive to negative. Negative 1 over 30. 1 over v equals 3 minus 2 over 60 equals 1 over 60. The distance of image equals 60 centimeter. We can find. Secondly, we will find magnification. If you remember, our magnification equation m equals, we are using the two equations. Firstly, if you're giving the height, we are using the height of the image over height of the object equals minus, when we are using distance between the object to mirror and distance between the image to mirror. We know distance of the image and distance of the object. We will use this equation. Magnification equals minus v over u. We find the v equals negative 60 over negative 60 over we know 30 equals negative 2. Magnification, 2 meaning image magnified 2 times. And second questions, a concave mirror having a focal length of 15 centimeters. Where should an object place in front of the mirror or form an image for it? Question: real and 3 times magnified and virtual and 3 times magnified. 1, real and 3 times magnified. Secondly, virtual and 3 times magnified. Our equations, if you remember our equation about magnification, magnification equals minus v over u equals, it's say 3 times magnified. Its meaning 3 over 1. Its meaning negative v over u equals 3 over 1. If we are multiply the cross multiplications equals v equals negative 3 times u. Its meaning the object distance of the objects 3 times far away to distance of the objects. And then we are using the what is the distance of the object, what is the distance of image. We are using the 1 over f focal length equals 1 over v plus 1 over u. And you know, we find v equals 3 times. But when we are using about these parties, we are not using negative. Negative, it is showing only virtual or real. And it is giving the focal length 1 over 15 equals, I am writing, we know V equals 3U. 3U plus 1 over U equals 1 over 15 equals 3 plus 1 over 3U. Equals 1 over 15 equals 4 over 3U. We can simplify 15 over 3, 5, 15 over 3, 1. And cross multiplications, U equals 20 centimeter. And we find U, and also we can find V, because of V equals 3 times U, 3 times 20 equals 60 centimeter. This is firstly, yani real and 3 times magnificate. Secondly, the virtual and 3 times magnificate. And we find V equals 3 minus U. And applying the general laws, 1 over F equals 1 over U plus 1 over V. But this part is we will use minus 1 over 15 equals 1 over U minus or plus, I will put the minus here, 3U. 1 over 15 equals, I will multiply 3 this part, I will multiply 1 this part. 3 multiply 1, 3 plus 1, this is negative, it must be negative multiply positive, it will be negative. We can change, this part is negative. Negative 1 over 3U equals 1 over 15 equals 2 over 3U. We can simplify 3 over 15, 5, 3 over 3, 1. We can find 2 times 5 equals U. U equals 10 centimeter. And if you remember, we find V equals negative 3U. We find the U, V equals 3 times 10, 3 times 10, but it is negative, equals negative 30 centimeters. Negative, it's giving it's meaning the virtual image. And answer is V equals 30 centimeter. Negative, it is showing the virtual image and erect and magnified. And another questions and last question about these chapters. A convex mirror has a radius curvature of the 8 centimeter, and object placed in the front of the mirror of 6 centimeter from its pole. Find the distance of the formed image and magnification power. First, it is this question about the convex mirror. And firstly, I am drawing one object, and every time it's about the convex mirror, the position of or distance of the image between the focus length and the image. This part is we can show V, this part is we can show U, and we can show power and we can show H. And this point is between this point of focal length. And it is first it is giving radius equals 8 centimeter, and an object placed in front of the mirror of 6 centimeter. It is giving the U equals 6 centimeter. It's 1 V, and normally we don't know F, but we know F equals 1 over 2 radius, and we know radius F equals 1 over 2 multiply radius. It is giving 8 centimeter. F equals 4 centimeter. Now I will using our equations. 1 over F equals 1 over U plus 1 over V. But focal length, it is giving the another side of the mirror. We are using the negative. Negative 1 over 4 equals 1 over 6 plus 1 over V. Negative 1 over 4 minus 1 over 6 equals 1 over V. Both of them is negative. 1 over V equals, when we are multiply some number about the 4, we will multiply 3 times 4, 12, and if we are multiplying 2 times 6, it will be 12. It must be we can use it. And negative 3 minus negative 2 over 12 equals 1 over V equals negative 5 over 12. V equals, if we are multiplication, cross multiplication, 12 over 5 centimeter. We find the image distance of the image. Now we will find the magnification of this question. And we know we find 12 over 5. It's meaning approximately 2.4 centimeter. And we know U equals 6 centimeter. And if you remember our equation, magnification equals negative V over U equals. But if you remember, this is negative. We find negative about the equations, negative 2.4 over 6 equals positive 0.4 magnification. The result is positive. Positive is meaning image is virtual. If you remember, I say you will memorize the four main information.